photovoltaic generation of electricity. Friends, today we are discussing the generation of electricity through solar photovoltaic system. Solar PV generation system is the major system for generating electricity from natural sources. Solar photovoltaic plant, it is also called solar photovoltaic power generation system. This direct conversion of solar energy into electricity energy take place. The effect of generation of electricity from photovoltaic cell is called photovoltaic effect. One of the important technology to generate the power from natural source is from sunlight. In this system, two similar two dissimilar materials in close contact produce an electrical voltage when struck by light or radiant energy. Discrete pockets of light energy, known as photons, strike the photovoltaic cell, knocking the electrons in the silicon material out of their normal energy state, which conduct as electricity. The photoelectric effect only occurs when photon strikes an atom in the solar cell. Amount of energy depends on material of solar cell from which it is to be made. The solar cell is not able to convert all the different wavelengths of light which are hitting on it. Therefore, solar cells are tuned during manufacturing process to absorb the spectrum of sunlight that is most intense. This phenomena exploited to form the individual solar cell on wafer of silicon. Since silicon is naturally reflective in nature, each photovoltaic cell is typically covered with an anti-reflective coating to minimize loss due to reflection. The figures showing the photovoltaic effect from which electricity is generated through sunlight. There is another figure showing the solar PV system in which radiation of solar can be absorbed by the solar panels, and solar panels generate the DC power, DC electric current. Then this DC power is converted to AC power and given to battery as a DC power or given to consumer as AC power. The solar cells in the PV solar systems, there are modules. Modules are consist of slides shown in figure. There are frame, glass structure, encapsulament of solar cells up and downs. Then below there is a back seat and junction box. Above figure shows the structure of modules. Common modules are hermetically sealed. Two layers of ethylene vinyl acetate are used as encapsulant. Top support is of toughened glass. Bottom support is of duponate Tedlar polyvinyl fluoride sheet (PVF) sheets. It is sturdy and suitable for outdoor use. Solar PV panels comprises of PV cells. Solar PV cells are connected in series and parallel combination to form modules. PV cells are made with silicon, gallium arsenide (GaAs), copper, indium biselenide (CIS), cadmium telluride (CDT), and few other materials. PV panels comprises of PV modules, also known as solar panels, battery system, charge controller, inverter. One silicon cell generally produces 0.5 volts. 36 such cells are connected together are called PV modules. It has enough voltage to charge 12-watt battery. Modules can be connected together to form an array or to generate more power. The wattage output of PV module rated as peak watt, that is WPA. Figure shows the cells, panels, strings, panels connected in series, arrays, that is panels connected in series and parallel system. Series parallel connection of the solar cells. If cells are connected in series, voltage of the cells added. If cells are connected in parallel, current of the cells are added. These are the basic principles. Parallel series combination of cells decided voltage and wattage of the module. Some logic is applied for modules and to form arrays and solar fields. Below figure shows the series parallel connection of solar cells. Figure shows the parallel connection and series connection of solar panels in series parallel, where two panels connected in series so that their voltage is added to 24 volt, where three strings connected in parallel so their current is added, so it's 30 amperes, that is 10 plus 10 plus 10 amperes. Types of PV cells. Types of PV cells are monocrystalline silicon solar cells, polycrystalline silicon solar cells, thin film type cells, amorphous silicon, cadmium telluride, copper indium diselenide. Appearance of solar cells and modules. The figure shows the appearance of monocrystalline solar cell, polycrystalline solar cell, and thin films. What is the solar PV cell technology? Single crystal silicon, also called monocrystalline, its efficiency is from 13 to 17%. Multicrystalline silicon, also called polycrystalline, its efficiency ranges from 11% to 15%. Amorphous silicon, also known as thin film silicon, its efficiency ranges from 6 to 8%. Concentrated SPV like silicon, GAS, CIS, CIGS, CDT, etc. Efficiency is vary from 25 to 30%. Rooftop solar. Now, many of houses and small commercial undertakings can generate their own power by installing rooftop solar. Polycrystalline modules are solely suitable for rooftop solar. Has slight cost advantage, relatively easier availability, good efficiency, least degradation, better life of cells. Inverter. What is inverter? Inverter convert the DC power into AC power. The following methods are used as per power requirement and capacity. Central inverter and multiple inverter. The figure shows the central inverter and multiple inverters, where one is denotes the PVRS, one A and B are part PVRS, then 2 indicates the PV combination box and 3 indicates the inverters. Now another figure shows the string inverter. What is string inverter? Here the entire string is connected with a single inverter, that is called string inverter. The figure 1 denotes the PV array, 2 denotes the DC isolator, 3 denotes the inverter, and 4 denotes the grid. Now another figure shows for the inverters installed individually for individual modules and connected to grid. Figure shows the grid connected solar system. It is showing how the radiation of solar can be converted to DC power through solar modules. Then there is a DC isolation switch. Then there is an inverter which converts DC power into AC power. Then there is a C side isolation switch Then again it is connected to PV generation meter. Then power goes to power equipments through main fuse, and some power is goes to AC mains supply through bidirectional energy meter, that is to grid. Thanks for visiting my videos, watching my videos. Please feel free for any comments in the comments box. Don't forget to like and subscribe so I can get energy to publish more and more videos. Thank you very much.